Hello, welcome to SINCON 2021. I'm Sebastian, and my talk is going to be about the beauty of remote code execution. Right? First of all, a short disclaimer. So, of course, as an ethical hacker, you should never target a system or network that you do not own or have permissions to test. But of course, hackers gonna hack, so hack the planet. Disclaimer number two, the opinions expressed throughout the presentation are solely my own and do not express the views or opinions of my employer. A short little agenda. So first doing a little bit introduction, and then we're looking into remote code execution, and then the end of the talk we're looking a little bit more into server-side request forgery, which is probably the future of remote code execution. So we're looking a little bit more into this topic at the end of the presentation. And we'll see, of course, remote code execution everywhere. Short introduction. So myself, I'm Sebastian. So 2009, I actually studied in Germany together with Deutsche Telekom. And 2012, I went into the internal SOC as a security analyst, but then very hands-on with security products. 2015, I actually got to Singapore. I had my first job here with My Republic, local telco. 2019, I actually shifted gears and went into a fintech startup and got a little bit more hands-on with regulatory requirements in that space. And then 2020, I actually joined 8x8, working on various products, call center solutions, communications platform as a service, your whole API layers, how to secure that, sending messages and so forth, right? And also very involved in the Singapore cybersecurity community as a whole, right? So let's talk a little bit about RCEs, and let's begin with definitions. So what is RCE actually? So when you look into Wikipedia, actually there are two main definitions. One is arbitrary code execution, which is the ability of the attacker to actually run any commands on any hardware, local machine, or remote machines, right? It's very, it doesn't specify where to run it, it's just that you have the ability to run arbitrary commands, right? Where remote code execution actually refers more to the ability of the attacker being away from the machine where the command execution is happening, right? So it could be over the internet, but can also be over a local network, right? As long as the attacker is far away, then it's considered remote code execution, right? And then at the beginning, I thought, let's talk a little bit about root causes. And I think there are two main root causes which can basically lead to RCEs. And I looked it up in the latest published OVAS 2021. It's not yet finalized, but it's in draft state. But now, there we got a new category which combines the insecure design. Right, and then in insecure design you have two CVE numbers which refer to upload vulnerabilities that can happen. Right, the first one was about the unrestricted upload of a file with a dangerous type, and the second one is a reliance on the file name or extension of externally supplied files. So we will look a little bit more into this in detail, how those vulnerabilities actually happening and how to exploit these, right? So first, the uploaded files really represent a significant risk to any web application because it gives the attacker the opportunity to actually get code stored on a remote system, right? So once you get code stored, the second step is actually to get code executed, right? But using any kind of file upload functionality in a web application is already giving you at least the option to store code, right? So that's a very first hold as an attacker to get into a system and to penetrate then further, right? Then you also have the first issues is about file metadata, like file paths or file names, right? And this kind of metadata is usually generally provided by the transport layer, such as HTTP multipart encoding. So we look into this a little bit later in the presentation. And this data may trick the application into overwriting a critical file or storing the file in a bad location, right? So especially when you think about file path traversal attacks, then that's what's going to happen, right? That I can actually write files maybe outside even of the web root, right? So it's very important for a developer to actually validate even metadata extremely carefully before making use of it, right? And the other issues rely then on file size or file content. So the range of problems here really depends entirely on what the file is being used for. So to protect against this type of attacks, we need to analyze everything the application does with files and think carefully about what processing and interpreters are being involved here, right? For a few examples, it really depends on the context of the application. So for example, if you have a web application, it might be dangerous to actually allow to upload customized JSP files, because then the attacker can run those as part of the Java installation, right? Or imagine you have an upload of images and then you do some resizing maybe, right? So those images can also be malicious, tricking the actually resizing process and doing something that was unexpected for the developer, or you didn't think of sanitizing certain things, or there might be other vulnerabilities in the resizing operation itself, right? Or what we talked about, the earlier slides was also about file size. So imagine you have a limited space on your web server and somebody is uploading huge files or a huge number of smaller size files, right? Then those can also lead to issues if you run then out of space on your web server, for example, right? And there are a lot of other examples as well, which can lead to problems later on, right? Or imagine you are allowed to upload exe files, and then you try to phish victims, and they're using the victim web server then to download malicious exe files, right? And misusing those web servers in file distribution. Or another example would be cross-site scripting, right? Once I can upload HTML files onto a victim web server, I can actually trick somebody into getting cross-site scripting in their browser context being executed. So also a huge risk actually, right? So that's why it's very important to look carefully about file upload functionalities, right? The second big class I wanted to talk about was OS command injections, right? And this is a little bit of a tricky topic because some people are not considering OS command injection as remote code execution, because the application already has the functionality to execute OS commands. But more often than not, OS command injection basically leads to arbitrary command execution, right? So that's why I thought it's also important to include this into the presentation. And when you look into this example maybe, so we see that that here we have a command being defined as cat, and then we concatenate it together with arguments which are user supplied, right? And then the system command is basically executing the cat command concatenated with user supplied inputs. So what we see here is that a legitimate usage is to use this wrapper and run it together with a file name, expecting that cat would actually read the file name, right? But what can happen is that an exploit is actually expanding the file name, concatenating it with another command, and what will happen is that the normal cat command that was pre-programmed will take the input file, but the semicolon will expand the whole line and execute another command, which is then being controlled by the attacker, giving you basically arbitrary code execution, and leads here in this example to an OS command injection, right? To simplify this example, you see here again we define a command as user bin cat, and we concatenate it together with user supplied input and then run it in a system command, which leads again to OS command injection, basically, right? Okay, let's look at those two categories, file upload vulnerabilities and OS command injection vulnerabilities in a lab environment. So I used the DEM vulnerable web application. So if you want to try it yourself and play around with it, then do consider the following slides as spoilers, because I will explain a little bit more about the vulnerabilities there, right? And you look at one functionality of the DEM vulnerable web application. You have this input, and you can actually enter an IP address, and it will offer you a ping for free, right? And this could be in a legitimate web application as well, that some kind of OS commands are actually being hidden behind in the backend, but you have a front end form where you can actually enter information which will then be used in the backend process itself, right? When you look into the source code of this form, you will actually see that we will have a shell execution in PHP defined with the ping command and the target. And again, the target is being user supplied input, and it's not being sanitized but written to the CMD and then just outputted via an echo statement, right? And that again leads to OS command injection, because I can expand in the last form with an IP address and then maybe a semicolon and then expand to an arbitrary command, right? The second one, I'm gonna go a little bit more into detail. The file upload vulnerability in the DEM vulnerable web application. So again, it looks like what you see sometimes when a web application is asking you to upload maybe a profile photo or other files. So you have a prompt where you can actually click browse, select your file from your local machine, click upload, and then the magic's gonna happen, right? And when you look a little bit more into HTTP request and response, then you will see that once you upload a legitimate picture, you will have a post request to an endpoint vulnerabilities upload, and then having an HTTP multipart defined from line 19 to line 30 in this example, right? And this includes what we talked about previously, metadata, right? So the metadata here is, for example, the file name, which is then what the file name that you actually selected from your local machine, and also the content type, which in this example is image/JPEG. And then I selected a normal 1 by 1 pixel, which is a JPEG, right? And then we see as a response in verb, actually the file path of the uploaded file is also being inside the response from the web application, right? So the web application tells us where this uploaded file actually lives and can be retrieved, right? Which is very important from an attacker standpoint, right? When we actually go to the path, we will see that this 1 by 1 pixel is actually being displayed at the bottom half of the picture, right? So we know that we can successfully upload files, and we have also the ability to retrieve those files, right? And what we want to do, we want to escalate this to remote code execution, right? So in the next example, what we actually gonna do is to use a file name, and we remove the .jpg and replace it with RCE PHP, right? So we try to upload the PHP file. The content type we will leave as image JPEG. Also, do note on the JFIF, which is a valid metadata information for JPEG images, right? So we can actually trick the web application to believe it's a valid image. But we will expand the image and will actually put PHP code at the end of the image, which is your PHP info. And PHP info is actually non-invasive method to test if you can actually retrieve further information about the underlying web server and the PHP interpreter, right? But this proves already that you have arbitrary code execution at that point, right? And then again, we will note that the file being successfully uploaded, and we actually get the output path back reported, right? So we can actually go to the page and see if the image is actually being executed from the web server, from the PHP interpreter, right? So in the next step, we will go to the address, and we will see a lot of the metadata information from the JPEG still being valid and being there, but it's not being interpreted by PHP because it's simply garbage for PHP, right? But once we get into the PHP tag, we see that the PHP info page is actually being displayed. So this proves that we have arbitrary code execution on this web server, right? And when we look into one more detail, it's that the damn vulnerable web application defines multiple security layers, and we see that actually under security medium, we are not allowed to upload a PHP a file with PHP extension and the text PHP content type, right? So this means that in this example, I actually went and clicked browse and selected the PHP file directly from my local hard disk, right? So then the front end will already put it as content type txt PHP, which will not be accepted. So the image was not successfully uploaded. But what we thought just now from our methodology to just leave it as image JPEG, it actually bypasses the restrictions that were implemented in the web application, right? So there was some kind of blacklist being defined, and txt PHP was being filtered out, right? But we prove that we can actually bypass this with image slash JPEG, right? But I know what you're saying now. You probably want to see a reverse shell example, right? And the thing is that you should not use web shells in an engagement because it adds a new vulnerability into the system. So what you should try is to use PHP info because it's a non-invasive method to actually prove arbitrary code execution, or use a reverse shell and being just connected back to your own machine, right? And then again, there's this awesome GitHub repository, payloads all the things, and they're extremely valuable examples being given. And there are a few examples also about PHP and which functions you should use for using reverse shell and connecting it back to yourself. So you can look that up and try those commands as well, right? And let's talk a little bit more about the upload path, because in the previous example we saw that the web application is giving you an output of the upload path, right? But what if you need to guess or you need to fuzz the upload path? So how would you go about that, right? So I looked and found this nice example in a nice Medium post from a researcher where a web application actually included a timestamp in the original request, right? So that this is again user supplied input, which we can just customize to match whatever value we expect and we know from an attacking standpoint. And he saw that whenever he uploaded an image, it was generated as user ID, a random number, and then whatever's file size there was as a PNG image, right? And he saw this number and actually concluded that it is the Unix epoch timestamp. So it's not random, it's just the time. So it's important to also recognize those patterns and be able to conclude when something is just time and not cryptographically strong, right? Another thing I wanted to emphasize here is the RC 7231, which actually specifies that an HTTP response should have a date header being set, right? So this date header is also giving you an idea of what time is it on the web server, which gives you the response, but also if it uses the Unix time or whatsoever, then you can actually narrow it down to the specific second when the request actually, when the response actually being sent back to you, right? So this gives you a lot of help to actually narrow down the time of the response. And one more thing which I found quite interesting was unique ID as a PHP function, and this was actually a prefixed unique identifier based on also the count time in microseconds. Okay, but it has a caution set in the PHP manual, which already specified that this does not generate a cryptographically secure value and should not be used for cryptographic purposes, right? We have basically the first 8 hex characters as the Unix time in hex, which there are converters out there and websites where you can enter the count time or any timestamp and it will actually give you the Unix time in hex, which is very helpful. And the last 5 hex characters are microseconds, right? And there are actually examples, and this researcher went a little bit ahead and did like a white box analysis of one application in this example, and he figured out that the password recovery, your normal I forgot my password, sending you an email with a token, had an MD5 hash but was using unique ID inside, which means that whenever you know the time the hash was generated, you could actually replicate the same, reproduce it, and then know the hash, right? So what he did was to came out with a POC where he generated 10,000 tokens because of the microseconds, and were able to brute force the correct token to basically did an account takeover, right, of arbitrary user accounts, because he could just guess whatever password reset token the application would generate, right? Because again, from the HTTP response, maybe you know the date and time, but it's only second. But then you can brute force basically the rest of the microseconds. So that again proved that unique ID should not be used whenever you require cryptographically strong methods, right? Let's look a little bit more into real-life vulnerabilities. And the first one also I took from Medium because it makes it so clear the thought process and how you go about it. So this researcher was actually fuzzing around and figured out that there was an admin panel, and he were able to like change his details using the admin endpoint. But there was also an option to upload a new logo, right? So the first thing that came to his mind was to upload an SVG file, because this was giving him the opportunity to trigger a cross-site scripting attack, right? Non-privileged, but to anybody who visits the URL, right? Which is cool, it shows impact, but we can escalate it. So he thought further and tried to upload files with a PHP extension. So the same what we did with the damn vulnerable web application. We uploaded it, but it failed with the PHP extension, right? Then he tried also this method in having a valid JPEG, but expanding the valid JPEG with arbitrary code, which could be the PHP info function. So he selected it, he clicked upload, but then he intercepted with burp and changed the file name to rce.php. And he successfully bypassed the restrictions because the web application thought it's still a valid JPEG because the content type was maybe set as image JPEG, or it was checking the metadata, which was still a valid JPEG, which was expanded as PHP. But once you have an RCE.php, the .php will instruct the web server and the PHP interpreter to execute the file and then prove that the researcher got arbitrary code execution onto the system, right? And the other example which I wanted to showcase here was an OS command injection, and I think this is like such a brilliant example of somebody also thinking out of the box. And the application was actually providing him a form where he could input a name, and then what he got was a voice file which basically said his name or whatsoever. And he was able to actually think out of the box and expanded this to an OS command injection in expanding this with arbitrary commands, right? So he used the semicolon to instruct the bash process that the following is a command which needs to be executed, and was able to enter the command, and the output was not being displayed by the web application, but was actually being read to him via the eSpeech command on Ubuntu host, right? And it was really a fun vulnerability, I think, to actually hear the OS command injection and being replayed to yourself, right? Another thing I wanted to talk about and get you a little bit more thinking is what if I have an XSS on a system but I want to escalate this even further? Can I actually escalate this to an RCE? Is this possible? Because XSS mainly lives in your own web browser, in your browser context, so how would you actually escalate this? And as I was reading around, I figured out that most of the game plans where that you have to compromise an admin account, so you need to get the admin to actually execute your cross-site scripting, and this being executed in their browser. So you use a SSRF to make a request on the admin's behalf then, and since the admin dashboard might have an upload capability, we can actually use this to make them upload a shell and achieve our remote code execution goal, right? So the cross-site scripting would trigger in an admin's browser and then uses their admin web upload functionality to upload our shell or our commands, malicious files, onto the system, right? So also like an interesting way to maybe show a little bit more impact once you have a cross-site scripting on the system, and you can actually have access to upload functionalities from admins. The last part of my presentation, I wanted to talk a little bit more about SSRFs. So a short introduction to SSRF as a whole. It's server-side request forgery, which is a web security vulnerability that allows an attacker basically to induce server-side applications to make HTTP requests to an arbitrary domain of the attacker's choosing. Right. So in a typical SSRF attack, the attacker might cause a server to make a connection to an internal service within the organization's infrastructure. But in another case, the attacker might also choose to force the server to connect to an arbitrary external system, potentially leaking sensitive data such as an authorization credentials. So how does it look like? The attacker on the left side will need to go to a firewall, and then the web server is being exposed, right? But once the web application is actually being vulnerable to an SSRF, we can use the SSRF to pivot further into the internal network and maybe target applications such as Elasticsearch, Kibana, Redis, MongoDB, which otherwise would not be exposed on the public internet, right? So SSRF is tricking the server into making connections into the internal network in this example. And now the question is, why do I bring it up in a talk about RCEs altogether, right? And I found she made a very, very good point in her tweet here, that she said that SSRFs must always be treated as RCEs unless proven otherwise. While there are cases where it is not, but these are really, really slim cases, not all RCEs, of course, are SSRFs, but damn near every SSRF is an RCE. So what does she mean with it, right? This means that in our current world where everything is going more and more into cloud, we can also think about the internal network as your cloud infrastructure. So if we are able to trick your web application to retrieve keys from, for example, the metadata service inside the cloud, we can take over your entire cloud, or parts of your cloud at least, right? So SSRFs means it's very, very dangerous, especially in cloud environments, but not limited to cloud environments. So it's really like the same level of impact. And if you are like interested in more to learn about SSRFs, then I think those slides from Nahamasek was actually really, really interesting, how they used PDF generators to render pages and retrieve information from the internal network, right? So for example, if you have an endpoint which just says fetch and an argument being given as URL, you can try to rewrite those URL and pivot further into the internal network, or target who's outside, and make the web application to actually fetch those URLs. Right. And then again, you're not limited to URLs and websites. You can also target files on the local system, or Gopher, or SSH even. Right. And if you're interested, then also I highly encourage you to watch this video where hackers are actually targeting Lyft and used the expense report creation, which used in the backend WEasyPrint, and was actually also vulnerable to SSRFs. So they were able to target the internal network using the expense report creation functionality in Lyft. At the very end of the presentation, I would like to emphasize a little bit about quality reports and impact, right? So we always say go deep or go wide in a sense. So imagine you found a cross-site scripting somewhere. So now we saw that actually if you are able to upload cross-site scripting, then try to go even further and try to upload reverse shells or PHP info functions or whatsoever, and try to get those executed on the web servers, on the PHP interpreter, to actually achieve arbitrary code execution, which shows a way higher impact than just uploading a cross-site scripting file maybe. right? And of course, this is Billy, and he takes time to write quality bug reports, and he's always nice to judges. So be like Billy. Right. So thank you so much for coming to my talk here at SINCON 2021. And when you're in Singapore, you can join actually the local cybersecurity group community, Division Zero. Show up at our meetups, or if you are if you are active in the bug bounty space and you have a HackerOne profile, also consider joining our Singapore club. You can reach out to me, and I can give you a little bit more information regarding that. So once again, thank you so much for having me and listening to my talk.